The National Communications Network, in collaboration with the National Center for Resource Development and the Ministry of Education, present CXC in Focus, a focus on the key subject areas of mathematics and English for students preparing to write the exams.
Welcome to another program, CXC Mathematics in Focus. Lesson 41, Geometrical Construction. In this lesson, we will be constructing geometrical shapes using lines and angles. First, let us construct using ruler and compasses only angles of 60 degrees, 120 degrees, 90 degrees, and 45 degrees. Constructing 60 degrees. We are given line AB, and at A we want to construct using the pair of compasses an angle of 60 degrees. Center A and a convenient radius, draw an arc from B going through C, then center B without changing the radius, make another arc to cut the first arc. That point is C. We join A through the intersecting arcs, and if we use the protractor and measure the size of that angle, it is 60 degrees. Construction of 120 degrees. At point A on line AB, we use a suitable radius and center A, draw an arc going all the way to the left without changing the radius on the pair of compasses. Center B, draw another arc to intersect the first arc, and that intersection is at C. Previously that is 60 degrees. Then we put the pair of compasses at C, center C, make another arc without changing the radius to cross the first arc at D. So we have 60 degrees and another 60 degrees. So if we join A through the intersecting arcs on the left and produce it and name that point D, then we have angle BAD equal to 120 degrees. Construction of 90 degrees. Similar to the first two, center A and a suitable radius, draw an arc through B. At B, same radius, draw an arc at C. Center C, draw another arc to cross the first arc at D. So the angle moving from B to C to D would be 100 and 20 degrees. From C to D would be 60. B to C would be 60, so we need 30 more to give us 90. So it's easy to find half of 60, and it is the second 60 we are going to bisect now to find the 30. This time we can change the radius on the pair of compasses. Center C, make an arc above as shown just next to E as seen, and then without changing that radius, center D, make an arc to cross the first arc earlier just next to E as shown in the diagram. And if we join A to E, the angle BAE is equal to 90 degrees, and you can confirm that by actual measurement. Construction of 45 degrees. 45 degrees is half of 90. So once we would have constructed up to the 90 degrees, then it's easy to bisect 90, and that will give us 45. Notice the line at F. It's crossing the first arc that would have been drawn. So B to F, following the arc, B to F will give us the angle 90 degrees. So we have to bisect that angle. So again, any suitable radius, center B, make an arc which is next to G there, and center F, make another arc to cross at G. If we connect A to G, the angle BAG is equal to 45 degrees. And note, many students, instead of putting the center at F, would put the center at E to give you the 45, to do the bisection of the angle. That is incorrect. We always have to use as our reference the first arc drawn, that is following B to C to F to D. That's the arc. We'll always use our reference arc to do bisection. Drawing the perpendicular bisector, please see that, not Victor, bisector of a line. We are given line AB, and we are asked to bisect the line AB using the pair of compasses. Now, at center A and a suitable radius greater than half the length of AB as estimated, make two arcs, one above, one below. Then center B, without changing the radius, make two similar arcs, one above, one below, to cut the two previous arcs. The arcs intersect above at C, the arcs intersect below at D. If we draw a line connecting C to D, we would discover that the line AB is divided into two equal parts. That's why we say bisecting AB. And if we measure the angle at the intersection, we'll discover that it is 90 degrees. Hence we say perpendicular bisector of line AB is CD. Drawing a perpendicular to a line from a given point outside of it. We have line AB, and the point P is outside of AB, that's at the top of AB. And from the point P, we want to draw a line that is perpendicular to AB. How do we do that? We use our compasses, center P, and a suitable radius, draw an arc to cut AB at the 2 points shown there. In this case, you can change the radius or keep the radius. The center where the arc cuts a line, you draw two other arcs, not above but below, as shown there. So the two arcs intersect at C. Connecting P to C but stopping at the line will give us a line that is perpendicular to AB. We use the broken line to show continuity of the perpendicular line to AB. constructing an equilateral triangle of side 5 centimeter. First, we draw AB using our ruler to measure. We have 5 centimeters. Then we take our pair of compasses, measure 5 centimeter as the radius, and then at A, center A, make an arc above, center B, make another arc to intersect the first arc. So we have 2 arcs intersecting at C. If we join A to C and B to C, we will discover that AC is equal to AB is equal to BC, which in turn is equal to 5 centimeters. And if we use our protractor to measure the size of the angles, we'll discover that the 3 angles are equal. Each angle is equal to 60 degrees. In any equilateral triangle, the size of one angle is 60 degrees. Constructing a square of side 6 centimeters. We know that the sides of a square are all equal and that each angle is a right angle, and there are several approaches in handling this construction, but this is one of several. First, we draw AB of length 6 cm. Then at A, construct 90 degrees, which we did earlier. Then we measure AD to be the same 6 centimeter. At D, you open your pair of compasses 6 centimeter and draw an arc near to C as seen. Then center B, you draw another arc to cut the arc near to C. That intersection, when B is joined to it and D is joined to it, will complete the construction of a square. If you measure the lengths of the sides, each is equal to 6 centimeters and each angle is equal to 90 degrees. Let us look at a problem taken from CXC January 2007. Part 1. Using a pencil, ruler and a pair of compasses only, construct triangle ABC with BC equals 6 centimeters and AB is equal to AC, which in turn is equal to 8 centimeters. And note the examiner's guidance here. All construction lines must be clearly shown. Part 2. Draw a line segment AD such that AD meets BC at D and is perpendicular to BC. Part 3. Measure and state A, the length of the line segment AD, and B, the size of angle ABC. Here is the solution. ABC is 6 centimeters, BA and AC 8 centimeters. From A, we drop a perpendicular to BC, so center A with a suitable radius, draw an arc to cut BC at 2 points, and at those points of intersection, draw 2 arcs below. Connecting A to the intersecting arcs below and stopping at the line BC will give us AD. You name that point D. If we measure the length of AD, we'll discover it is 7.4 centimeters. and if we measure the size of angle ABC, we will find that it is equal to 68 degrees. In doing geometric construction, you should follow the following guidelines that will allow you to obtain the highest possible mark for the question. And these are some guidelines for you. Ensure that the legs of the pair of compasses are firm, that is, they are not dangling or slack. Ensure that the instruments you carry to the examination room are not new, which would mean that you would not have practiced with them. The pencil you use for geometrical construction is either 1H or 2H pencil. Avoid using HB pencil. Avoid erasing construction lines. If you have to erase, drop that E from 2. If you have to erase, use a quality eraser, not rubber eraser. That will remove only pencil mark and not the fiber of the paper or smudge your presentation. The calculator should be a scientific calculator and one that you have used extensively, not a new one. The diagrams or shapes constructed must be labeled as instructed by the examiner. Use a pair of dividers and a ruler to take accurate measurement of a line. It is usual to first draw the longest line given in a horizontal position. Try to estimate the position of the construction on your answer page so that it can fit without having to do the construction all over. Here is your problem for today. A. Using a ruler, a pencil, and a pair of compasses, construct the triangle ABC, in which AB is equal to 8 centimeters, angle BAC is equal to 60 degrees, and AC is equal to 5 centimeters. And notice the examiner's guide here. Credit will be given for neat and clear diagram. Part B. Measure and state the length of BC. Part C. Find the perimeter of triangle ABC. Part D. Draw on your diagram the line CD, which is perpendicular to AB and meets AB at D. Part E. Determine the length of CD. F. Calculate the area of triangle ABC, giving your answer to 1 decimal point. This is the problem given to you in the last lesson, CXC June 2005. The latitudes and longitudes of Antigua and Belize are given in the table below. Antigua 17 degrees north, 62 degrees west. Belize 17 degrees north, 88 degrees west. Calculate the shortest distance between Antigua and Belize measured along their common circle of latitude. Part 2. A tongue, Bahia Blanca, situated in South America, lies on a meridian 62 degrees west and has a latitude of 38 degrees south. Calculate the shortest distance between Antigua and Bahia Blanca measured along the common circle of longitude. Here is the solution. To find the shortest distance between Antigua and Belize, to find the radius of the circle at 17 degrees north, little r is equal to big R cos theta, where big R is 6,400 kilometers, which is the approximate radius of the Earth. So 6,400 cosine 17 degrees is equal to 6,120.3 kilometers. But angle AOB is equal to 88 minus 62, which is equal to 26 degrees. Therefore, 26 over 360 times the radius, which is 2 times 3.14 times 6,120.3 is equal to 2,775.9 kilometers. The distance between Antigua and Belize is 2,775.9 kilometers. Solution continue. Part 2. Calculate the shortest distance between Antigua and Bahia Blanca measured along the common circle of longitude. The circle of longitude is common. The radius of this great circle is 6,400 kilometers. But angle AOB is equal to 17 plus 38, which will give us 55 degrees. Therefore, 55 divided by 360 times the radius, which will give us 6,140.4 kilometers. So the distance between Antigua and Bahia Blanca is 6,140.4 kilometers. This brings us to the end of today's program, CXC Mathematics in Focus.
In this lesson, we will continue to look at figurative language. 1. Analogy. An analogy is a comparison between two objects or ideas in order to show ways in which they are similar. In effect, analogies say A is to B as C is to D. The resemblance between the objects and ideas is partial, but close enough to provide a striking way of illuminating the relationship the writer wishes to establish. An example of this is pollution affects the environment the way cancer affects the body. You should recognize that a simile is an expressed analogy and a metaphor is an implied one. When we write our short stories and speeches, we often tend to compare one thing with another without using similes or metaphors. Another example of analogy is, when I think of this young man working, I always remember my half-dead grandfather. Or, to hear him speak is to bring back memories of that glorious era of the 50s. As you listen to this program and prepare for your examination, think about the analogies you can come up with when you think of the following. The loud laughter of our baby sister. A friend who is faithful to you. A friend who has betrayed you. A rowdy neighbor. Minibus drivers. A rainy day. A neighbor playing excessively loud music. Flooded streets. Now let us examine hyperbole. This is extreme exaggeration that is not meant to be taken literally or at face value. The purpose of hyperbole may be comic or emphatic. Sometimes in your report of certain events or proceedings, you may want to emphasize a particular aspect. Many of us watching the cricket matches at the recently concluded World Cup series would have experienced a range of emotions, ranging from exhilaration to almost unspeaking depression, especially in relation to the performance of the West Indies team. One can imagine, for example, the response of a die-hard fan of the West Indies cricket team who has been asked about the result of a particular match. What happened? Australia murdered them. Of course, we are not meant to take the word murder literally. Similarly, we often say to our friends that if we get caught doing certain things that are prohibited, our parents would murder us, that we would be put into the cooler, or that we would see hell. Little children as well as adults who recalled childhood events are likely to put a spin on incidents so that these incidents appear more serious or gruesome than they really were. When we retell the whipping given to us in our early days at school, we often say that we received licks like peas, or a child that sees a few mosquitoes in his or her net will report to the parents that there are millions of mosquitoes in the net. A child who gives another a few cuffs or jabs may say that he left the fellow half dead. Often, the term hyperbole is used to color our perception of events in the political arena. A particular political party may keep a meeting in a certain district, and 5 or 6 people may attend. The report of the attendance would very often indicate the presence of a mammoth crowd, or huge crowd, or a crowd bursting at its seams. A massive rally may actually be a few persons milling about. Such language is exaggeration or hyperbole for specific emphasis or effect. Another kind of exaggeration that we are accustomed to and know so well is the one we use for comic effect or humor. Often, these fall under the category of tall tales. Dave Martin's Cricket in the Jungle and Paul Keane Douglas's Exploits of Tanti Merle and the fabulous tales of the adventures of our son Balgobin all fall into this category. We are aware of the tall tales that are told about people in our community with respect to eating, drinking, smoking, fighting, and our battles with supernatural forces. Wakes, fetes, funerals, and such are occasions when the storytellers among us excel. Litotes, or understatement, is the opposite of hyperbole. In this device, we deliberately understate things rather than exaggerate. We may refer to someone who is wealthy as a person with a few cents. A student who has passed 10 subjects at CSEC, all with grade 1s, out of modesty, may admit that he passed a couple of subjects. We are aware that many of our Amerindian brothers and sisters travel long distances on foot to get to school, to their farms and other places. Often, the destination is just around the corner. The expression, "she is not bad looking," may actually refer to someone stunningly beautiful. Having a drink or two may actually mean a really heavy drinking spree. Having a bite or two may actually mean gluttony. Someone gone for a day or two may really be absent for a long period. Someone making a huge profit on a business deal may refer to this amount as small change. Often, the word not is used to emphasize this understatement. Not too bad, as a reference to a student's performance at school, may actually mean a good performance. To say she was not unmindful may mean she gave careful attention. To refer to a child as not ungrateful may actually be a reference to someone who is attentive, kind, and caring to his or her parents. Someone not on the thin side may be a person who is fat and terribly overweight. Metonymy. This is a figure of speech or device that is characterized by the substitution of a term, naming an object closely associated with the word in mind for the word itself. In other words, something is named that replaces something closely related to it. For example, in the statement, City Hall has decided to embark on a campaign to collect all outstanding rates and taxes, really refers to a decision made by the City Council. City Hall, therefore, stands for municipal authority. When we listen to the news on radio or television, we recognize that this is a widely used device. Washington, London, Moscow, and Beijing are words used to convey the authority of the governments of the USA, Britain, Russia, and China. Similarly, the Vatican refers to papal authority. The expressions, the pen is mightier than the sword, and those who live by the sword shall die by the sword, are all examples of the use of metonymy. In the following lines, scepter and crown must tumble down, and in the dust be equal made with the poor crooked scythe and spade. Scepter and crown is an expression that refers to the aristocratic classes, while scythe and spade is one that refers to the common people or the working class. Onomatopoeia as a device is a word or combination of words whose sounds seem to resemble closely the sound that it denotes. Words such as hiss, buzz, rattle, bang, butt up, whim, sizzle, bam, whisk are thought to be onomatopoeia. Allusion. This is a device used to refer to a time, place, event, or person in the past to evoke certain feelings and emotions and to add to what is being discussed. Allusions take several forms. In some texts, the word biblical allusion is used to refer to events and personalities in the Bible. But for us, we will use the term religious allusion or scriptural allusion because of our multi-religious and multi-ethnic society and the widespread use of allusions other than biblical ones. The use of the terms Eden and Judas, Satan, the Rock of Ages, Calvary, the road to Damascus are all terms that refer to important events, personalities, or ideas in the Bible. Similarly, terms such as Hijra, Ramadan, Idul-Azha, Idul-Fitr, Yom Nabi are words that have specific significance in the Islamic tradition. In much the same way, words such as Ayoda, Satyam, Bharat, Ravan, Sita, Yamraj have peculiar Hindu association. As students, we should make every effort to understand such allusions, for knowledge widens our understanding of the various groups in our country. In addition, we make use of words and phrases that may be classified as other types of allusions: classical, literary, and historical. Such expressions as Helen, Cleopatra, Trojan horse, Pandora's box, Waterloo, Romeo, Don Juan, Puppies, Timbuktu, Massacuruman, Old Hague, Baku, Titanic, Crusoe, and a host of others can be used to admirable effect. An understanding of such allusions enhances our appreciation of a rich, varied culture that informs our present situation. Apostrophe. This is a device in which the writer makes an address to a person or thing, not literally listening. Wordsworth, for example, begins a sonnet thus: Milton, thou shouldst be living at this hour. And Shelley begins an ode by apostrophizing a skylark: Hail to thee, blithe spirit. In speaking to his disciples, Jesus suddenly breaks off and turns to the city and says, Jerusalem, Jerusalem, how often would I have taken you under my wings, but you would not. This is a moving example of the use of the apostrophe. A moving American spiritual has these words: Death, ain't you got any shame? At a more mundane level, if you are writing a letter to the editor on the hazards faced by school children in minibuses, you must suddenly use a diversion and address the drivers and conductors in this way: Don't you have children of your own, or nieces and cousins and other relatives? Why then do you allow and encourage the abuse of our young girls? This is an example of the use of the apostrophe. Pun is generally recognized as a play on words, and while it has uses in serious literature, very often it is used for comical purposes. The reference to mender of souls in Julius Caesar can refer at the same time to souls, S-O-U-L-S. How does a pun operate? It reminds us of another word or other words of similar or identical sounds, but a very different denotation, meaning, or application. When asked to tell the difference between men and women, Samuel Johnson replied, I can't conceive, madam, can you? You would recognize that the word conceive in Johnson's reply can be interpreted in two ways: to think or imagine, or to bear children. The name of a dentist's country estate, Toothacheres, is accurate. Aching feet paid for the property. Try to recognize the puns in the following. Ben Battle was a soldier bold and used to war's alarms, but a common ball took off his legs, so he lay down in his arms. The second one, golden lads and girls all must, as chimney sweepers, come to dust. 3. Thou art Peter, and upon this rock I will build my church. Alliteration is the repetition of a speech sound in a sequence of words and is usually only applied to consonants. The following are examples of alliteration language. After life's fitful fever, bring me my arrow of burning gold. When to the sessions of sweet silent thoughts, out of this house, said the writer to the reader, the fair breeze blew, the white foam flew, the furrowed followed free. You may recall that in your earliest school days you were required to cram a number of verses that are referred to as tongue twisters. These are also examples of alliteration. Two examples are, a flea and a fly got caught in a flue. Said the fly, "Let us flee." Said the flea, "Let us fly." So together they flew through a floe in the flue. Peter Piper picked a peck of pickled peppers. A peck of pickled peppers Peter Piper picked. If Peter Piper pickled a peck of pickled peppers, where's the peck of pickled pepper Peter Piper pickled? As we advised earlier, the use of figurative language is underspread both in speech and in writing. Your aim should not be to cram and parrot definitions, nor should it be to fill your essays and stories with ornamental expressions. Your aim should be twofold: to recognize and evaluate the use of figurative devices in speech and writing, and to use to impress others, but to make your language creative, fresh, and effective. So boys and girls, until the next lesson, I'm Ingrid Pound saying thank you on behalf of Bibi Ali, Parmeshwar Lal, and Ron Chichester.
The National Communications Network, in collaboration with the National Center for Resource Development and the Ministry of Education, present CXC in Focus, a focus on the key subject areas of mathematics and English for students preparing to write the exams.
Welcome to another program, CXC Mathematics in Focus. Lesson 42, Vectors. In this lesson, we will examine the properties of vectors and apply them to geometrical theorems. First, let me explain to you what a vector is. A vector is a quantity that has both a magnitude, that is size, and direction. Examples of vector quantities are weight, displacement, velocity, acceleration. Here are examples of vectors, pictorial representation of vectors. Read in the direction of the arrows. So we have vector AB as seen on the top left. Then vector XY, we read X to Y in the direction of the arrow, not Y to X, X to Y. Vector RS, going from R and ending at S. Vector PQ, starting at P and ending at Q. These are examples of a pictorial representation of vectors. The same vectors, when represented using vector notation or a column vector, vector AB is expressed as 2, 1. That is, from A, you go 2 units to the right and 1 unit up. So vector AB is a free vector 2, 1. What about vector XY? Vector XY, moving from X to Y, we go along the x-axis, then the y. So vector xy is equal to 3 minus 1. That is, from x you go 3 units to the right and 1 unit down, which will give us vector xy equal to 3 minus 1. Vector rs is the vector minus 3 minus 2. That is, starting at r and moving to s, we move minus 3 units, that is, from r 3 units to the left and then 2 units down. So vector rs is equal to minus 3, 2. Vector pq, moving from p to q along x, the x and then y, we have vector pq is equal to minus 2, 2. Meaning that if we start at p to get to q, you move 2 units to the left and 2 units up and then you reach q. So vector pq is equal to minus 2, 2. Vector notation. Let's look at some of the notation that we have been using commonly around. There seemed to be a problem with the computer which is showing a symbol over the small a. Well, I will explain what that should be. AB written with an arrow above is read vector AB, which is equal to, we can represent that vector using small a, bold small a, with an arrow over the a. Shouldn't be something looking like a P. It's an arrow that should be there. And that is equal to 2, 1. Sometimes if we can't have the line above AB, we can have it below AB as seen on the right. So sometimes you would see in this program we use arrows above and arrows on. Vector xy, written xy with an arrow over xy, that can be represented using a small letter b, vector b, b with an arrow over it, which is equal to 3 minus 1. And if we use a parallel notation, it will be xy with an arrow under it. Vector pq, notice the arrow is missing over pq. Vector pq is equal to small letter c, say, with an arrow over c, and that is equal to minus 2, 2. Can be written in the other way, pq with an arrow under it or a line under it. Vector rs is equal to d, if we name the vector d with an arrow over it, and that is equal to minus 3 minus 2, and can be written as rs underline. Let's look at properties of vectors. Vector A is equal to 2, 5 and vector B is equal to 3, 7.